tell if it is a nice y-intercept. So please look at 1 through 6 and circle the numbers that have really nice y-intercepts that you're like, oh, this makes my life so easy. And then I'm going to have you kind of talk to each other with which ones you'd say have the same, have a nice, easy y-intercept. Because some of them, I can't tell that much. Like 3 and 4 are kind of ugly, right? So is number 1 nice? What is the y-intercept in number 1? 0, 1. So in my equation that they asked me to write in simplest form, the only thing I really need to find is my slope, right? And I have the equation because that's my y-intercept. 2, is it nice? Super nice, right? 3, not nice. This question, because this y-intercept, I really can't tell if it's 0.25, 1/3, 0.4. I have no idea where that's at. I am going to start this with point slope form. Because I know a point on my line, and you only need 1 point, and then I'm going to count to get my slope, rise over run. Okay? I would do the same in number 4. I would start number 4 in point slope form. Because it kind of looks like it's almost, like these are going by 2s, so it kind of looks like maybe it could be 7, but it could be 7.5, it could be 7.25, I don't know, right? So I'm going to use point slope for those 2. Whereas for questions 1, 2, and 5, I would definitely use slope intercept, right? 1, 2, 5 are beautiful slope intercepts. Number 6, I'm going to use point slope form again. So if I was going to start, so if there are questions on 3, 4, or 6, because I think the other ones are easier, anyone want to do one together, or are you feeling okay and we just go to the marble slide? Because it doesn't matter to me. Anyone's thoughts feel? Our first point over here looks to be where? 6, 10, right? Our other point, if I'm taking a look at that one, Claire, is -4, -2. So when I think of my change in y's, Grace, how far am I going from -2 to get up to 10? What is my slope? From -2 to 10. How far did I go up? 6. Careful. -2 to 10. Watch the numbers, not the scale. So it's super easy to think of going up, but what is our scale? Our scale is going by 2s. Oh. Yeah. So thank you for making that mistake, actually, because a lot of people will do that. They're like, oh, this is just 6, but I mean, you could kind of do that, but let's just use our numbers. So -2 to 10 gives us 12, and it's positive. And now I'm going across, instead of I'm looking at my x coordinates, I go from -4 over to 6, which means I'm going across 10. I'm going to simplify this to 6/5, right? Just because if I have my fraction or my slope in simplest forms, it's easy. Okay. So I'm going to write my point slope equation. Y equals. Start me off, Olivia. 6/5. Do you want parentheses? Yes. Okay. X minus Andrew what? That depends what point you're using, right? Which one do you want to use? 6. I'd go with the positives too. X minus 6, and then we're going to have what? Plus 10. So this one they asked us, we can't leave it like this, right? Because this is point slope form, and at the top it says you must simplify this to get it in slope intercept form. So we are going to start doing some multiplication. Celsius, we're going to multiply, distribute. Six times 6, because this is really over 1, so I'm going to have minus 36/5 plus 10, right? And this is really tiny. over 1. So if I wanted to put it over 5 instead of 10 over 1, it actually would be what? If I wanted 5 as a denominator, it'd be 50, right? That's the same as 10 over 1. Why do I want to do that? Because now I have a negative 36 plus 50. What is 36? Negative 36 plus 50, or 50 minus 36, gives us 6x plus a negative or minus how much? 20. So 36 minus 50 minus 36 gives us negative 14. Fifths? Yes? No? Yep. So, put it, yep, everyone okay with that? Not 24 or 14. Okay, now, if I'm leaving it, I could leave this as my answer. How many times is 5 going to 14? I'm thinking about that. Comes out to be a negative or a positive. Negative we have here? Should it be negative? Should it be negative? Some here are yes, some here are no. Okay, so let's look at it. 5 goes into 14 2 times. 2 and 4, 2 and 4 fifths, and we think it's negative. Wouldn't a negative 2 and 4 fifths be right here? So wasn't my mistake, isn't this positive? 50 and 30. Oh, and so now it's positive. And does this look like this could actually be 2 and 4 fifths? It very much looks like that. That's like on that last quiz that you took. Some of you told me the y-intercept was here, and that doesn't even make sense. So y equals 6 fifths x plus 2 and 4 fifths. Could you have just left this one? Yes. Okay. But when you write that equation, you got to make sure that this matches here. They have to be exactly the same. So that when I look at 2 and 4 fifths or 14 fifths, that has to match here. And if it's not close to it, then you made a mistake someplace. And that's what you got to kind of watch for. Okay? Making this equation. So when I look at fix 4, I might put in another new equation. I'm going to start typing y equals. I might change my domain here to be ending at 8, right? Or maybe I decide to end it at 7, or I end it at 9, and I still think it's going to work. And then I come up with another equation. Now my other equation, I might use the same slope or I may not, right? Then you get into the predicting. They're going to ask you to change one thing in this. They're going to say, oh, what if we change the slope from negative 0.14 to 2? What's going to happen? So you'll write. Always share with your class, please. Notice if you want to put something in with math type, you click on this and it'll go to math type, or you can go to the keyboard, okay? When you're at your keyboard, as you look at that, you can also go, I want to show you when you're putting in equations. Let's go to so how do you get these brackets? To get the brackets, what you're going to do is if you click on the keyboard down below, this keyboard. So the ABC gets you to the brackets. And I'll help you today in class as you're working on these. So you do some more predictions and verifying. They ask you to keep doing it. And then you get to screen 15. And it says, okay, the challenge. And I ask you to do 3 challenges. So this is the first challenge. Might an absolute value going down equation be perfect? But I might want to limit the domain, right? So how do I get absolute value? I go y equals, and I click on my absolute value here. And I go, oh, where do I want the vertex to be? So I might need to look at my equation. Oh, I want the vertex like right below here maybe, right? So think of how we write those equations in point slope absolute value form.
And then I want it to go down. So, oh, you know what? In front of this, I want it to be a negative. And I'm just going to put something in, like I'm going to put x minus. So you saw my graph. It was here. So maybe I go with x and I go minus 8, right? Oh, I moved it right there. And now I do outside my absolute value. So to get that back absolute value, I have to click it again. And now I want to go plus 15. Not equal 15, but plus. So just by kind of playing around with these, I can see, that kind of took one of them out, right? But maybe I don't want the domain. So now I click back here and I go to the ABC button and I click this bracket and I say where x is less than. And so again, now I might go to the numbers. And I want to say where x is greater than, I need to look at my numbers. So x is greater than 8. So I only get that side of it, right? What if I change this, because 8 was my vertex point, what if I change it to a 6? Oh, now I get that part of it. So you can change the domain by putting it like this. You might have many different equations. So when you get to the challenges, do you have to use absolute value? Nope. Someone else could have used slope-intercept. Y equals 3x plus 2. Right? So, oh, that didn't happen. But you can write many different equations. And again, you're going to try and get that to cancel out. So that's what you're kind of working